Hello, we are Group 2. My name is Robert. With me is Samuel, Justin, Bradley, and Thomas. And this semester we worked as a team in the IMSC department at Iowa State University, working with the Interventional Radiology department at a large Midwestern hospital. A background of the problem: the current scheduling system in the department had no methodology for scheduling patients and procedures. They performed up to 61 different procedures, each had their own constraints, and the constant rescheduling through the day proved to be a hassle. Some constraints and assumptions we were given. The procedure times are based on a min and a max, and they were given to us by the hospital. The salaries for the doctors were researched from the internet. And then the two types of patients we dealt with were inpatients, which were generated through the simulation software we used, and the outpatients, which we manually generated using RStudio.
Our group started off by creating simple scheduling schemes covering 5 weeks of simulated daily procedures to generate some results. The scheme started with short procedures first, where, as it sounds, the day started with shorter procedures, meaning there were more patients scheduled for the morning. Next was long procedures first, to get what should take the most time done first in the day. The next scheme was creating a block schedule, which grouped scheduled procedures by type so that the same procedures would take place consecutively. With the results from these, we were able to create more in-depth scheduling schemes that we thought could yield better results, staying consistent with the 5 weeks of generated daily procedures. Those scheduling schemes included short procedures around long procedures, where we would set longer procedures farther apart with shorter procedures around them to limit the number of overlap of these big procedure slots. The next complex scheme was pre-procedure requirements first, meaning procedures with any kind of necessary steps preceding the procedure, such as sedation, would get prioritized for earlier in the day. Next, we created a scheme based on scheduling outpatients for earlier in the day to help mitigate the fluctuation associated with their arrival times. The last scheme tested was organizing a schedule to include less procedures on Mondays and Fridays to allow for some buffer when patients get added quickly to compensate for the weekend.
Simio is a discrete event simulator that allows us to test multiple scheduling parameters. We were able to model the waiting room, 4 IR rooms, the CT room, ultrasound room, and the sedation base of the hospital. Patients move realistically between the different stages of the process, and each patient is assigned 1 out of 61 procedures, which dictates parameters such as their operating time, room requirements, and whether or not they need sedation. Providers like doctors and nurses are also simulated, with their overtime and downtime tracked on every run. Inpatients arrive following a Poisson distribution, averaging 2 patients per hour, and outpatients arrive based on our created schedules.
After creating our simulation in Simio, we ran experiments 100 times. With these results, we ranked the average values from 8 to 1, with 8 being the best. We then created a weighted criteria matrix that you can see here. Our weighted consisted of giving overtime a 1, utilization a 2, downtime a 4, and wait time a 5. After calculating these values, the scheduling outpatients early was the best, closely followed by scheduling short procedures around long procedures.
As stated before, scheduling outpatients was the best found scheduling scheme, with short procedures around long procedures in a close second. By scheduling more outpatients in the morning, it allows the schedulers to find time for the inpatients later that day, thus relieving the pressure of constantly reworking the schedule to find time for those inpatients. These top 2 scheduling schemes could also be combined, opening up more possibilities for possible schedule improvements. The economic impact for this project focused on the overtime for the doctors and the PAs. Since no data is available on employee salaries, estimates were found through research for both the doctors and the PAs. Using this data, the top 2 scheduling schemes can be compared with the control to find an economic impact. This table shows the impact for just the doctors for a 5-week span. It is important to note that overtime is not the most important criteria for this project, so some other schemes may save more money than the top 2 schemes.
Finally, once we are done with this project, we will be providing our documents back to our client. These documents will include our Simio file with our experiments, our total list of procedures and the data that we have collected, and our final report document. This way, when they start changing and making adaptations to their IR department, they can update these documents and redo the experiments.